This class is a little bit long, so we are going to divide it into two parts. Today we are seeing the first part. We will start by defining what a curve is. A curve is a continuous set of points that is very close together, okay, with no spaces. Now, we were seeing yesterday, lines are a continuous set of dots, so lines are part of the curves. Also, segments and rays are part of the curves. Now, two-dimensional curves can be considered simple when they don't intersect with themselves. Here we have some examples. Also, they are closed if they start and end in the same spot. Okay? We're going to classify these four into simple, not simple, closed, or not closed. Okay? Here, do we have lines intersecting with themselves? No, they are not intersecting, so it is simple. Does it end and begin in the same point? Yes, so it is closed. Next, is this a simple curve? Yes, because it is not intersecting. And does it begin and end in the same point? Yes, so it is also closed. Is this line intersecting? No, so it is also simple. Does it begin and end in the same spot? No, so this time it is not closed. Does this line intersect with itself? Yes. So it is not simple. And does it begin and end in the same place? Yes. So it is not simple, but it is closed. Now we are going to focus on polygons. Polygons are figures that are in a plane, and they are made by simple enclosed segments, okay? Not any kind of curve, but specifically segments, okay? We can classify polygons into two kinds, convex and concave. Convex types of polygons are the ones whose angles, all of them, measure less than 180 degrees, while concave have at least one angle that is more than 180 degrees. You have two examples in your presentation. And now, polygons are named according to their number of sides. Okay, we can start by 3, since they are segments. We cannot have a 2-segment polygon because it wouldn't be closed. So we start with 3 with triangles, then we go with 4, which are quadrilateral, 5 is pentagon, 6 is hexagon, and from there on they are all going to end with gon. We are just going to add the Greek prefix for the number of sides. For example, 9 is a nonagon because the Greek prefix for 9 is non. The Greek prefix for 10 is deca, so a 10-sided polygon is a decagon, and so on. Now, there are other classifications of polygons. We can have regular or irregular polygons. Regular polygons are the ones that have the same measure for each of the sides and also the same measure for each of their angles. Okay? Most of the polygons we know are regular polygons. For example, squares, hexagons, regular pentagons, etc. Focusing on the very first or the very basic polygon, which would be our triangle, we can classify triangles depending on the length of their sides. Okay? We have 3 different types of triangles depending on their sides. First, we have the equilateral triangle, which means equi means equal. It has 3 equal sides. This is the only regular triangle. Okay? Remember, regular polygons have the same measurement on their sides. So this is the only regular triangle, equilateral triangle. Then we have the isosceles. The isosceles triangle has 2 equal sides and 1 different side. And the third one is scalene triangle. A scalene triangle has no equal sides. So, isosceles and scalene triangle are irregular polygons. Another way to classify triangles is by their angles. Triangles can be classified by their angles, just like angles. Okay? We have acute, we have right, and we have obtuse. Okay? Acute triangles are triangles that have all of their angles as acute angles, meaning all of their angles measure less than 90 degrees. Then we have an obtuse angle, which would be a triangle that has one obtuse angle. Okay? One of their angles measures more than 90 degrees. And last, we have a right triangle. A right triangle is a triangle that has one right angle. Okay? One of their angles measures exactly 90 degrees. A very important thing is that we know that every time in every triangle, doesn't matter if it is scalene, isosceles, equilateral, acute, obtuse, or right, all of the triangles always, if we measure all of their angles, they are going to add up to 180 every time. Okay? So let's call this triangle ABC. Triangle ABC has angle A, angle B, and angle C. If we add angle A, B, and C, we are going to get a total of 180 every time. So if we have 2 angle measurements and we are missing the third one, we can get it by using an equation. Let's say angle A measures 100 degrees and angle C measures 30 degrees. We know that the total of the angles should be 180. So we know that 100 plus 30 plus the third angle, which we don't know, should be equal to 180. we can isolate the A to find the measure of the angle, which for this specific case would be 50 degrees. Now if we add 100 plus 30 plus 50, we would get 180. So that's it for today's class. Tomorrow we will continue. Next class we will continue with the polygons topic. So I hope everything was clear enough. If you have any questions, please log into the Facebook Q&A live. And I hope you have a great day. Bye bye.